right, so today's warm-up is about the skill they talked about where you're trying to solve something by graphing. Now, number one and number two, I would never, ever probably go to try to solve this by graphing. In practice, it'd be a lot easier just to move things around, right? Get the x's on one side, right? The numbers on the other side. So it might seem stupid, like, why are they teaching us this skill, you know, when it's so much easier why would I go solve this by graphing? I wouldn't. Well, let's go see why real quick. Because sometimes they get bigger. Number three is a big, old, ugly mess. It's not in this unit, but probably the easiest way to go solve that. In fact, the only way to go solve it would be by graphing. So it is a useful skill to learn. And let's dive in with the warm-up and see what we can do. So, number one, in order to solve anything by graphing, your job is to get it equal to the magic number of 0. We're going to graph it and see where it equals 0. So this one, it doesn't matter which side you put things on, as long as one side's equal to 0. I'm going to move this stuff over. I don't know why not. It's arbitrary. If you add x to both sides and subtract the 5, then on the left, you'd have the x's would be gone, the 5's would be gone. You got 0. And that's the whole point. Over on the other side, you'd have 6x plus x. That's 7x. And negative 11 minus 5 is negative 16. So we have something compared to 0. We'll go get our graphing calculator out, and we will see where it exactly equals 0. We type it in just like it looks. We are trying to graph 7x minus 16, just that part of the equation. 7x minus 16. Always a good idea to do a zoom 6 and reset your window. And the 0 is wherever it crosses the x-axis there. So how do you find that with your calculator? Make sure you're always using your calculator to find these things. No guesses. Second calc. This is also known as a 0, x-intercept. It's where it's equal to 0. Makes sense. Go anywhere to the left of it. To the left of it. Go anywhere to the right of it. Hit enter. Guess doesn't matter. And you get some weird decimal out, but that's fine. Let's write it down. X is 2.28. 5714. It goes on and on and on forever like that or something like that. And that's good enough to solve by graphing. Now, the downfall is it's not an exact answer. You get some decimal thing, and hopefully it's close enough. If you'd actually gone and solved this thing really quickly, you would have got x's 16/7, which as a decimal is approximately this right here. So what's the downfall of graphing it? You get an approximate answer. You don't know exactly what it is. Probably don't look at this and think that that's about 16/7, but both are pretty good ways to go about it. I would always go this route. I'd find it exactly if I could, but if you need to solve by graphing, then that's the point of that. Let's do another one real quick. So number 2 today, we got 1/2 x minus 2 is 1/4 x plus 1/3. So I put fractions in this one just to jack with you. Nonetheless, let's get all the x's on one side and all the numbers on the other side. I feel like putting my x's on the left today, so I'm going to move this 1/4 over. So you subtract 1/4 x from both sides. And if I'm putting my letters, my variables on the left, I need to put all my numbers on the right. So while I'm at it, why don't we move this 2 over? We'll add 2 to both sides. And let's see what happens after all this. 1/2 x minus 1/4 x. Anybody know, just with number sense, what a half minus a fourth is? It's a fourth, yeah. So I got a 4th x. Sweet. Over there, you had a minus 2, but you added 2 to both sides, so it's gone now. So you got your x stuff all on this side. Over on the right, you had a 4th x, but you subtracted it, so those x's are gone. Now I just need to figure out what a 1/3 plus 2 is. Now, would you agree that 2 is 6/3? So 1/3 plus 6/3 would be 7/3. There we go. Now to finish it up, well, if we're going to solve it by graphing, we get everything on one side, right? Let's go 2 ways. Let's go just with algebra, and let's go with graphing. If you were going to solve it algebraically from here, the thing you would do is to get rid of this 4th. That's got to divide by 4, right? I'm like that. So we're going to multiply both sides by 4. And 7/3 times 4, or 4 over 1, if you multiply straight across, would be 28 on top and 3 on bottom. So the exact answer is 28/3. But we're supposed to be solving this by graphing. So going back up to this last step right here, we had 1/4 x equals 7/3. We need to compare it to 0. So move one of them over to the other side. Doesn't matter what. If you move the 7/3 over, you'd be really solving the equation 1/4 x minus 7/3 equals 0. Now, we already know what the answer is. It's 28/3. But we'll practice doing it with our calculator yet again. So y equals, and 1/4, how do you type fractions? You just do divide. 1 divided by 4 is 1/4. 1/4 times x minus 7/3. Same thing as always. You go hit graph or zoom 6 or whatever, and hopefully it crosses somewhere you can see. Barely way over there somewhere. So second calc, find the 0. Anywhere to the left of it. I'm gonna have to move over this far anyway, so might as well. There's something to the left, right. Go, make sure you go way past wherever it crosses. That's definitely above it now. And you get an answer of 9.333, which, guess what that is? That's 28/3. So try to avoid the decimals if you can, but try to get the exact ones always. I would not go solve those by graphing if I had my choice. It's a poor method. Unless you get stuck. The whole solving by graphing is for when you get stuck and you just don't see the path algebraically to get there, like number 3 is. Number 3 is way beyond our skill level right now, how to solve this thing. In fact, I don't even know if you could solve it algebraically. So, but the strategy would be the same. We're going to set it equal to 0. We're going to graph it and see what the answers are. Let the calculator do the work. So I need to get everything on one side. I'm going to move this stuff over. I'm going to subtract an x squared and an x and add a 1. Opposite signs of that. Of course, you got to do it on the other side too. Over on the left, let's see what like terms we had. We had an x cubed. Any x cubes down here? No. So I just got an x cubed. Can't deal with that. I have a minus x squared here. There's no other x squared, so there's a minus x squared still chilling. There are some x's we can put together. We had negative 2x's. We're subtracting an x. That'd be a negative 3x. And we also added 1 to both sides, so there's a plus 1. And this thing's equal to 0 also. I don't think that's possible. Well, it is. There's a cubic formula, but for the most part, that is not possible to solve algebraically. You have no prayer, so you go just type in your calculator. X to the 3rd minus x squared minus 3x and plus 1. Hopefully, when you graph it, you can see it cross somewhere. I see lots of answers. You see lots. I see 3 answers. Oh, 3 answers for this one. We'll just find one of them because the principle will be the same no matter what. Second calc, 0. I'm going to do the first 0, first place it crosses the axis. If you want to do another one, be my guest. First answer is negative 1.48-ish. I have no idea what that number is. Negative 1.48-ish. And there's 2 others, and we could go ahead and do them. I won't belabor the point. But the theme here is if you're in a jam, go ahead and set it equal to 0 and graph it. But nothing on the test will be that complicated like number 3 is. Everything you could do algebraically, so that's something that we want to learn how to do. All right, learning goals today. We are studying absolute value equations and inequalities today. It is a very set procedure. You need to take this equation, you need to turn it into this. And after that, it's very easy to solve, but you have to learn the process. When you take notes over how to do this, I would very religiously be looking at my notes while I'm doing my homework. I would be saying, okay, this is exactly what I set up based on the absolute value thing they gave me. And if you're very literal with it, you cannot go wrong. Homework's due today, 2.1. I know it's got a lot of problems in it with the set builder stuff and it's not accepting a lot of the answers, and that is not your guys' fault. The system is pretty messed up. So you'll be getting a lot of free points on that. Still do your best and try to answer everything to the best of your ability. I'll take care of you. I'm sure your grades will turn out fine if you're just putting forth effort like always. Of course, with the new topic today comes new homework, and then we have sections 2.2 homework going to be due in a couple days on Wednesday. Tomorrow will be a work day to work on it. Today, of course, we're going over it. So let's dive in. We're in Unit 2, notes, notes, notes. Here we go. Today is section 2.2. 2.2. Solving absolute value equations and inequalities. It's found on page 83 of your book. If you ever get stuck, check out your notes. Actually, the nice thing about a book is you can read it and it kind of teaches you on its own too. It's like a second teacher. So use that resource to look things up. All right, let's do some notes. Here we go. First things first. I would not write this down. This is a whole bunch of crazy stuff. I'll try to summarize it for you in a second. Here's the key thing maybe you might want to write down. We're studying today absolute values. We're going to study a lot of functions in this class. X squareds, exponentials, logarithms, all kinds of things that you don't know about yet. The key thing throughout all of them will be to get this thing that we're studying by itself, okay? Get it by itself, and then I'll tell you what to do after that. So if you see some absolute value things, get it by itself. Now, just to think things through real fast, let's try to figure out how we would solve an absolute value equation. What's this, guys? What's the absolute value of 5? 5, yeah. And what's the absolute value of negative 5? 5. So if I gave you this equation and said, okay, the absolute value of something is 5, what would be the two answers? 5 and negative 5. That's the first notes right there about how to solve absolute value equations. Right here is the big box. If you have the absolute value of something equaling a number, in this case, they're saying absolute value of A. So if absolute value of A is equal to B, for example, that means that that A is either B or negative B, just like the one we just did. If the absolute value of X is 5, then X is either 5 or negative 5. The absolute value of A is B, then A is either B or A is negative B. That's the key thing here. You will also find throughout this course, sometimes we have some strategy to solve something and we have to make some kind of secret, hidden, illegal move in there that you're not aware of. And it can sometimes give you an answer that does not work. It is possible to do some algebra work, do it all correctly, and get out an answer that just doesn't fit the initial conditions of the problem. When that happens, that's called an extraneous solution. Those will come up from time to time with different functions we have. It's basically an answer that doesn't work. So you need to know that vocab right there. An extraneous solution is a solution that you work on, you do some algebra, but it just doesn't work. It's not anybody's fault. It's not that algebra is wrong. It's just some techniques we have to solve things, introduce an answer that might not work. But I'll tell you what, if there are answers, our techniques will find them. Just sometimes it might find one that doesn't work. So something to watch out for is you want to check your answers, okay? Cannot emphasize that enough. If you do some work and you get an answer out, go back to the original equation, plug it in, and make sure it actually makes the original equation true. Sometimes you get no solutions out, nothing. Sometimes there's a dead end, and I ask you a question, it's just not possible to find an answer. When that happens, your answers are part of something called the empty set. Your empty set is it's a set. We don't use sets much, but we've been using set builder notation a little bit. But an empty set is just what it sounds like. It's completely empty. It has nothing inside of it because there's no answers. So I'm not going to make you do that one too much. You don't have to write empty set all the time, but just be aware that that's what the book might call it. Empty set, empty set, empty set. So key ideas on this, solving equations, whatever it is, have it equal that number, but also have it equal the negative value of that number. And go back and check your answers. You might have an extraneous solution, something that doesn't actually work, or sometimes you might have no solution. It just depends on the case. It's not that complicated after that. Inequalities are a little bit more tricky, so this is the easy one today. Let's take a look at an example, shall we? Okay, so here's our first example. Example 1, let's write it down. I'm going to do it. Looks like fun. 2 times the absolute value of 5x plus 1 minus 9 is 4x plus 17. This is actually a very complicated starting off point. Nonetheless, the concept will be the same. So if you go back, the first thing it says, all these notes say, is the absolute value equals something, correct? Absolute value A equals B. So you have to get the absolute value by itself first before you can do anything else. So we're going to move things around and get this absolute value all by itself. First thing we're going to do probably is how you're going to get that absolute value by itself. I would start by adding 9. Would you agree? Let's add 9 to both sides. So after I add 9 to the left, it's gone. Adding 9 to the right, what is 17 plus 9? 26. Okay, sweet. I like that. Now, is the absolute value completely by itself? No. There's a 2 in front, right? That sucks. So let's get rid of the 2. It's 2 times this thing, so we'll divide everything by 2. And I mean every single term. It's a balance. So if there's 2 things over there added together, you got to divide them both by 2. And now you've accomplished your first step. You have the absolute value by itself. 4x divided by 2 would have been 2x. 26 divided by 2 would be 13. So here's our setup right here. And now's where I got into my strategy. Okay, how do you solve an absolute value equation? Again, whatever it says, right? The absolute value equals something. You have 2 different equations. One of them, you just drop the absolute value. The thing inside the absolute value A is equal to the thing outside B. And the other one, you say the thing inside the absolute value A is equal to the negative of B. So going down that little path here, there's only going to be 2 options. I'm going to go down 2 different little equations. One of them, the stuff inside the absolute value, which was 5x plus 1, is just equal to whatever you already had, which is 2x plus 13. There's one setup. The other setup is the stuff inside the absolute value, which was 5x plus 1, is the negative version of the stuff you had on the right. Now, I'm going to be very careful with this. Make sure it's the negative of the whole thing. Note my parentheses right there. Negative of all of 2x plus 13. Whatever expression's over there on the right. The process makes sense so far. Questions over anything. Because this is essentially all it is of solving absolute value equations. Now we're going to go solve them both separately and see what we get out. So like anything else, we're going to get all the x's on one side and all the numbers on the other. If you subtract 2x, then this would be 3x, correct? If you move the 1 over, that would make this a 12. So I subtracted 2x from both sides. I also subtracted 1 from both sides. And finally, dividing through by 3, one answer is x is 4. We will do the same kind of thing going down the other path now. First thing I see, though, is there's a negative in front of this stuff. So let's distribute the negative into everybody. 5x plus 1 is the negative going into both of them would make this negative 2x minus 13 there. And same logic, we'll need to get all the x's on one side. If you add 2x over this time, that would make this a 7x. If you subtract the 1 and move it over, negative 13 minus a 1 would be negative 14. And then dividing through by 7, you have the answer of x is negative 2. So there's our 2 potential answers. Potential, but don't forget the new buzzword that we're learning right now. You might have had an extraneous solution. It is possible that maybe one of these does not work. So it's very crucial you go back and check them in the original equation and see what you get. So let's do that real quick. Let's check 4. Okay? Plugging 4 into the original dude. 5 times 4 is 20, correct? 20 plus 1 is 21. The absolute value of 21 is 21. Times 2 would be 42. And 42 minus 9 is 33, correct? This side would be 33. Let's see if the other side's 33. 4 times 4 is 16. 16 plus 17 is 33. So this one is confirmed. It definitely works for us. We're happy with that. -2 might work. It might not. You might not always have an extraneous solution. It just depends on the case. So let's just try it out and see what happens. -2. 5 times -2 is -10. -10 plus 1 is -9. Absolute value of -9 is 9. 9 times 2 is 18. 18 minus 9 is 9. This side would be 9. On the other side, let's try -2. 4 times -2 is -8, right? -8 plus 17 is still 9. So this one worked also. And it might seem that this is kind of stupid, like, oh, they seem to be working, but once in a while they don't. So it's extremely important that you're checking things right there. Okay, let's try one more. Let's try example number 2 today. We're going to get the absolute value by itself. And then we're going to split into those two cases where the absolute value is just equal to the positive version of the right side, and the absolute value is equal to the negative version of the right side. So right off the bat, be thinking to yourself, why is this absolute value not by itself? Well, there's a minus x on this side. That's the first thing I'd probably get rid of. So we're going to add x to both sides and see what happens after that. Adding x to both sides, we would have 2 times the absolute value of x plus 1 left over. And when you add an x to the right side, you had 3 x's. You just add an x, so you got 4 x's. Again, the absolute value is not quite by itself yet. I got this 2 in front. So we're going to divide everything by 2. There's a thing divided by 2. There's a thing divided by 2. There's a thing divided by 2. And the 2's will cancel, so you're going to have the absolute value finally by itself. The absolute value of x plus 1 equals 4x divided by 2. Well, 4 divided by 2 is 2, so I got 2 x's. And same thing over here, you got a minus 2 still chilling. Now that I have my absolute value completely alone, it is time to go down my 2 different paths. One of them, you just drop the absolute value. X plus 1 is, you don't do anything to the right side. X plus 1 is 2x minus 2. Cool. The other path you go down, you also drop the absolute value, but you negate, make the other side negative. So x plus 1 must be negative all of 2x minus 2. I won't bore you with the details, but if you solve this one, you get x is 3. Over here, if you solve this one, you get x is 1/3. You would distribute that negative in first. I did a bunch of steps in my head. Please actually do the steps, but I don't want to sit here and go over the same things we did last lessons, just moving things around, stuff like that. So I think you get that. Yeah, 3x. Yeah, x is 1/3. All right, go back and check them. I don't know. Does 3 work? 3 plus 1 is 4, correct? Absolute value of 4 is 4. 4 times 2 is 8. 8 minus 3 would be 5, right? Over here, what about 3? 3 times 3 is 9. 9 minus 4 is, again, 5. We're happy. 3 is a good guy. I like 3. 3 is awesome. What about a third? I don't know. Let's go see about that. 1/3 plus 1. Well, 1/3 plus 1, which is 3/3, right, would be 4/3. So this is 4/3. Absolute value of 4/3 is 4/3. 4/3 times 2 would be 8/3, right? And 8/3 minus x, which was 1/3, would be 7/3. So this side here will be 7/3. I wonder if the other side's 7/3. Well, let's find out. 1/3. 3 times a third is just 1, right? And 1 minus 4 is -3. Is that the same as 7/3? No. So this one is, what's the word what doesn't work? Extraneous. Yes, yes. Good thing I checked, because if I wrote that down in the test, so it was 1/3, well, I'd be incorrect because it's extraneous. So sometimes you got 2 answers, sometimes you don't. One more example. This one's shorter. This one has no solution. And when you have no solution, they say, okay, your answer is the empty set. It's the set of no answers. There's no answers in it. Nonetheless, strategy keeps being the same. So you got yourself the 4x minus 7 inside your absolute value. The first thing I think you would do is subtract 10 from both sides, and you'd get that 2 minus 10 on the right would be negative 8. Now, right off the bat, I can tell you this has no answer. Do you know why? What do absolute values do? They make things positive, correct? So what I'm asking you to do is, can something positive be a negative? No, already it doesn't work, correct? If you're smart, you see that, great. Then the answer is no answer, right? Well, let's just pretend we don't see it. So we'll go down our two paths anyway, and we'll see that we get out things that just don't work. Absolute value is by itself. So we'll drop it. 4x minus 7 is either the thing you already had, negative 8, or the stuff inside the absolute value is the negative version of that. Now, negative 8 would just be positive 8. Move things around. One of these answers, you would add 7 to both sides, divide by 4. One answer would be negative 1/4. The other answer would be 15/4. Let's go plug it in and see why they don't work. They don't work for the reason we just talked about. This is always going to be positive, right? So when I plug it in, I'm going to get positive. It's definitely not going to work, but we'll just confirm that. How about if I check negative 1/4? 4 times negative 1/4 is negative 1. Negative 1 minus 7 is negative 8, but the absolute value of negative 8 is positive 8, not negative 8. So that doesn't work. And by a very similar bunch of logic, if you checked 15/4, you'd plug it in and you get out something that's positive, and it would not work. So this has no solution. No solution. If you want to get all fancy, you can either write the words no solution, or you can put that new symbol they've had, kind of a 0 with a bar through it. That means empty set. That means this is the answers. There's none. There is empty. Sad like that. And that's pretty much all there is to solving absolute value equations. Now, it gets a little bit trickier when we're doing absolute value inequalities. You definitely want to write down this bar here, this box, and let it be your guide as to what to do in these situations. For brevity's sake, they are written for with less than or greater than. The same rules would work for less than or equal to, or greater than or equal to. Kind of confusing. Kind of confusing. Ideally, we would understand where these come from on a deep level, a conceptual level. That way we would remember what to do. Well, they're kind of tricky. As you write them down, you might want to put a star by the keywords and or. Those are very important. I should have put them in like big, bold, like italicized things. And is the keyword, or is the keyword for the other one. There's different strategies for solving something where it's less than or equal to. That's what that first line is for, if you have something less than something. And there's a second strategy if you have something greater than or equal to. That's the second line right there. And if you copy that down and are very literal with it, it'll work out. But I never just like to give you just blank rules and just say, just deal with it. I like to always get you to understand where they come from. So thinking about things, can you solve this equation? Can you give me any answer to this? Give me a number that makes this true. An absolute value means less than 5. Would 4 work? Would negative 4 work? 3? Sure. In fact, if you think about this on a number line, let's see about this. If I gave you this equation, I think you would say that anything between negative 5 and 5 would work. Would you agree? Yeah. Why did I draw open circles on these? It can't actually be 5 or negative 5, can it? What if I change the problem to this? Then what would you do? Then I have to close. Exactly. So right here, what they're saying is, the first rule is, if you have the absolute value of something that's less than a number, that means it's between the negative version of it and the positive version of it. So the first rule you had on there was, if the absolute value of something is less than something else, then the thing inside there, which in our case was x, has to be more than the negative version, correct? More than the negative version of it, and at the same time, less than the positive version. There's our first rule. Fair enough? Okay. Now the second rule comes from a weirder thing. What if I change it to greater than 5? Isn't that kind of the opposite of what we just did? We just found things that are less than 5. Greater than 5 are kind of the other stuff, right? If these are the things that are less than 5, then I guess the things that are greater than 5 must be the things outside of it. So the second rule comes from this red region that is shaded in right there. Now, how am I going to write this red region? Well, let's see. Here, we'd want all the numbers that are less than the negative version, correct? So we want all things less than negative b, or, separate piece over here, all the numbers that are greater than the positive version of it. So the second rule that was on the board a second ago is really just the opposite of the first rule. In fact, look at how they're backwards. If you're doing less than, we're looking for a is greater than negative b, right? Oh, if we're doing greater than, we're looking for a's that are less than negative b. Look at these two. They're just backwards, right? Here a is greater than negative b, here a is less than negative b. And the other piece, if a is less than b, well, this other option has a is greater than b. It's a little confusing, honestly. I remember that confusing me a little bit as a student when I was first learning it. So please just kind of write those down and follow them religiously. I'd like to understand why they're the rules, but let's just practice using them and see what we can do with it. Okay, here's our first example of this. Let's write it down. Solve this absolute value is less than whatever that number is, 11. I don't care whether you're doing equations or inequalities, the first step is always the same. You need to get the absolute value thing by itself. So in this particular problem, the very first thing you would do is add 5 to both sides. That way you got this absolute value by itself. And that would result in the absolute value of 4x minus 8 being less than 16. Now I go back to my little rules. I'm going to use them. It says if the absolute value of a is less than something, this is the first piece, right? Then I need to say that the thing inside the absolute value is greater than the negative version of it. So let's go down that path. The thing inside the absolute value has to be greater than the negative version of this thing. That is was 16, right? So greater than negative 16. Simultaneously, the key word here is and. This other path must be true. The thing inside the absolute value, second piece of this, must be less than whatever the number was. You don't have to change or anything like that. It's just 16. So I'm being very literal. Does everything match up to you? You see what A is? See what B is? A would be 4x minus 18 or 8, right? B is 16. I'm being very literal, plugging into this thing, and I can't go wrong in that case. Now we're just going to go solve it. So we're going to split into our two cases. We're going to go solve them each separately. This one, let's get the x by itself. We're going to add 8 to both sides. So 4x is greater than negative 8. Negative 16 plus 8 is negative 8. And keyword, over here if you add 8, 4x would be less than 24. And dividing both these equations by 4, I'm working with inequalities. Do I need to flip it? No, because you're dividing by a positive, right? But always be thinking about that. Don't forget that little thing. So here, one of them says x has to be greater than negative 2. And this equation says that x has to be less than, when you divide by 4, 6. The reason the key word here is and is because if you graph these separately on a number line, here is, let's say, negative 2 is right here. By the way, according to this piece? Should I have an open or closed circle? Open, yes. So all the x's greater than -2 would be this forever. Would you concur with that? Well, what about my other piece? Here's all the x's that are less than 6, right? So again, I go to 6, open circle on this piece too, correct? And this one gets shaded all the way for x's less than 6. Now, where's the answer? How can I have two pieces? That's why the keyword is and. Where is the purple line and the green line? Right in here, right? This is where they intersect. They're both here, A and B. So your final answer is this kind of little circled piece on a graph. And I do want you to kind of do that on a graph. So open circle on -2, because -2 isn't in both of them, is it? It's not this one and this one. No, that's an open one. But wherever they overlap, essentially. So graphically, your answer is this right here. X's are between -2 and 6, correct? Okay. Now, how I want you to write this answer. Graphing's cute. It's nice. But basically, I just want you to tell me all the numbers between -2 and 6. So I'd want you to give me good old interval notation. How about this? That's my answer. That's a chaining answer right there. Between -2 and 6 with parentheses because you don't include the endpoints. It's all coming together. That example makes sense? Okay. Let's try another one. It's tricky. I remember this being tricky. Let's try this one. This is a greater than or equal to. That's a separate deal. Greater than or equal to, I think I got to go do or stuff. But one thing at a time. Let's not try to do the whole problem in one shot. Let's get the absolute value by itself first. And we'll worry about the details later. Right off the bat, though, on this one, even while you're writing it down, what should you probably do first? Get the 3 on the other side? Let's add 3. There's no reason to, like, not do some steps while we're here. So this is our absolute value right here. 6 times the absolute value of x minus 4 is greater than or equal to 18. The absolute value is still not by itself. So let's divide both sides by 6. I'm doing inequalities. Do I need to flip it? I'm about to divide by 6. No, it's positive, but I'm always going to check myself because I don't want to jack it up. Okay, so we got this. X plus 4 is greater than or equal to 3. Now, I don't want to jack this up, so I'm going to go back to my notes real quick. Let's see. When they say greater than, what do I set up right here? The stuff inside the absolute value is less than, and that's in our case, well, let's see. Oh, yeah. Less than, should be less than. In this case, it's going to be less than or equal to. Right. All this stuff still works for equal to. Just put the equal sign on it. So first thing on this step is the stuff inside the absolute value, which is x plus 4, is less than the negative version of b. And b was, in our case, 3. So here's my first equation. And the key word on these greater than inequalities is or. This one or that one. What's the other version going to be? Well, the stuff inside the absolute value, x plus 4, is greater than whatever the number was, which was 3. So in our case, greater than or equal to, right? Okay. 2 equations. Let's see what we can do about them now. So we went down our 2 paths, just like it looked on the board, correct? We're all right. Let's go solve them, see what we get. This is easy. Just subtract 4, right? So x is less than -7. Or, in this case, if you subtract 4, x is greater than or equal to 3 minus 4 is -1. What's this look like on a number line? Well, let's look at these 2 pieces. X is less than -7. Well, oh, I lost some things, didn't I? What did I jack up? I was going off the board a lot more than the problem. These were all equal to, right? So they're all equal to. My bad on that one. This one's x is less than or equal to -7. So wherever -7 is, should I put a closed or open dot? Closed. Yes, I should. And then everything less than it. So to the left. So basically shaded way over to there. Fair enough. That's that piece. The other pieces are x is greater than or equal to -1. Here's, say, -1. This piece also has a closed circle, right? And we're looking for greater than that. Now, the key word here is or. So it doesn't have to be where both of them are. It's just one or the other. So it's either this piece or that piece. And that's a fine graphical answer. How would I want you to write? I want you to go negative infinity to something, blah, blah, blah. So negative infinity until -7. All right. So here's my answer. And I'd put a bracket on it because it can be it, right? I got another piece I got to deal with. So that's when you put that union thing, right? I'm going to glue two pieces together. And the other piece is bracket on -1 until positive infinity. Graphical answer, interval notation answer. They're all saying the same thing. But you see, I just got to follow the recipe. That's why you want to write that stuff down. It's confusing. They got a bunch of rules. You got to really stop and think about them if you want to do it from scratch. Like, oh, I'm just going to try and figure it out on my own. But I recommend just looking them up every time. Let's try one more. Example 6, same kind of deal. We got an absolute value thingy. This is a greater than or equal to problem, so it'll be very similar to the one we just did. Absolute value of 6x plus 3 over 2. Right off the bat, I just moved the 5 over. There's really no point to have a 5 on one side. Oh, yeah, 5 on one side and a 14 on the other. That's dumb. So, yeah, subtract the 5. The absolute value is not by itself. You have the absolute value divided by 2. Well, let's undo division by 2 by multiplying both sides by 2. So this is equivalent to absolute value of 6x plus 3 being greater than or equal to 18. All right, I don't want to mess it up. I'm not going to guess. I'm going to go back to my rules. This box is my baby. Here's my box. Says for greater than, I'm going to be very literal. A is the stuff inside the absolute value, so 6x plus 3. The first thing it says is it's got to be less than the negative version of the right side. So less than, or in our case, less than or equal to, correct? The negative version of the other side, which is negative 18. Or the stuff inside the absolute value, 6x plus 3, is greater than or equal to just whatever the right side was, which was 18. If you match things up right there, you can't jack this up. So I really want to emphasize just use this thing. All right, here we go. Getting x by itself really quick. If you subtract 3 from both sides, that would mean that this one is 6x is less than or equal to -21. Dividing through by 6, it's a positive. I don't need to flip it. So x is less than or equal to -126, which reduces, 7 goes in both those, right? Or no, 3 does. I'm stupid. -7 halves. Okay. Yeah, x is less than or equal to -7 halves. Going down the other path, subtracting 3, that would be 6x is greater than or equal to 15. Dividing through by 6, that would mean that x is greater than or equal to 15/6, which again, 3 goes into those and gives you 5 halves when reduced. So on a number line, what's your answer is going to look like? Well, where's -7 halves? It's like that's like -3.5. I don't really care. It's somewhere on the number line, right? And am I going to do a closed or open circle? Again, it's going to be closed. I'm looking for things less than -7 halves. Less than would be to the left. So right here would be this piece of solution. Similarly, this piece over here, I need x to be greater than or equal to 5 halves. So wherever 5 halves is, put your closed circle and you draw it filled into the right. So it's either on this piece or that piece. Either one's okay. Here's my graphical answer. And Shane'd probably like things on interval notation on the test. So how do I write this interval notation? All the shaded things are from -infinity until -7. 7/2 with a bracket, right? Because it can be it. And then I have this other piece to glue on that goes from 5/2 to infinity. Okay. Very much a methodical, straightforward process. It just takes a little practice, and I think the more you do of these, the better you'll get at them. You got any questions over the content? Okay, make sure you got those notes written down because they're your baby on this. Homework 2.2 is over this. You have until Wednesday to get it done and work time tomorrow. But there's a decent amount of problems, so you might want to get a good start on it. Thank you, guys.